Hey there, ladies and gentlemen, boys and girls. Today I'm going to show you guys how to balance a chemical equation or balance a chemical reaction. All right. So first of all, we think about some of the terminology we already know about reactants, products, subscripts, and coefficients. All right. I'll go over them real quick. So I have three reactions up here. What we start with is the reactants. Here are our products. And middle one arrow is what we call the yield. All right. The little number on the bottom there, those are called the subscripts. That tells me, in this case, how many fluorines there are. In this case here, I have XeF6. That 6 tells me there are 6 fluorines. There's no number here because we assume that there is a 1 and that there is 1 xenon. All right? And it tells us how those things are, and they are very specific to the actual reaction. We can't change those subscripts unless because that's a different chemical reaction. All right, in this case here, I changed the subscript on bromine. It was a 2, and now it's a 1, but that's because of how it bonds to magnesium. I can't just willy-nilly take this into a 3. If that's not what magnesium bromide is, that's not what it needs to be. So what I'm going to do here is I'm going to show you how to follow the law of conservation of matter, which says matter can't be created nor destroyed, but it can't be changed. All right, I can't destroy xenons in or fluorines, and I can't create fluorines, but I can rearrange them. Right now they're separate, and I can rearrange them to make them together. So I'm going to do 3 examples here. I'm going to kind of show you 2 ways to do it, and I'm going to kind of show you the thinking process on how to do this. All right, so make sure you guys have out your handy-dandy notebooks. All right, this last one I'm going to actually have you guys try on your own, on your notes, and then we'll check it and go through it together. Okay, so first thing I'm going to do is I'm actually going to do the second one first. All right, I kind of made my last-second decision here. All right, and so I'm going to do this one more conceptually, and then I'll do the other 2 by numbers. I'll show you what I mean by that. All right, so I have my reactants and my products. The law of conservation of matter says that, or law of conservation of mass says that whatever I start with is what I end with. So first of all, we have to think about what we're starting with here. So first thing I like to do is I like to work beneath the reaction. And I like to kind of draw a line to separate the reactants and the products. And I like to let's see what I have. So right now I have a magnesium that is bonded to 2 different bromines. It's stuck to 2 bromines. And here I just have a potassium atom by itself. Here on the product side, I have a potassium that is bonded to a bromine. That little dash, it's not a dash, it's a line that's representing a chemical bond or that relationship. And I have a magnesium by itself. All right? So first I have to see, I can't create or destroy matter. So in this case here, I started with 1 magnesium. I ended with magnesium. Makes sense. Here I started with 2 bromines and I ended with 1 bromine, which means I can't create matter. Or in this case, I can't destroy matter. All right? Which means I had to have had 2 bromines. But each one of these bromines on this product is connected to a potassium. So yes, I fixed one problem and potentially made another one. All right? So, okay, magnesiums are good, 2 bromines, 1 potassium, 2 potassiums, all right, which means I've had to have started with 2 of these, all right? So now it's balanced, the same number on each side. I started with 1 magnesium, end with 1. Start with 2 bromines, end with 2 bromines, start with 2 potassiums, end with 2 potassiums. You could even say I started with 1, 2, 3, 4, 5 total atoms, and I ended with 1, 2, 3, 4, 5 total atoms, which makes sense. It's conserved. It's not lost or created. All right? But I used multiple of these ones. And so I need to show that in my reaction. All right? And so what we do is we add coefficients. All right? These coefficients, all right, just tell us how many of them there are. I used 1 of these. So I used 1 magnesium bromide. I have 2 of these. All right. I ended with 2 potassium bromides. and I ended with just 1 magnesium. This reaction is now balanced and follows the law of conservation of mass, because whatever I started with, I ended with. My full reaction would be, magnesium bromide plus potassium makes potassium bromide plus magnesium. But it's kind of annoying, so we just put the coefficients in front of it. All right. So let's look at it from a different point of view. Let's do this first one here. All right. Again, I want to do it just with numbers. And this is what I like to call, when I'm doing it with numbers, you can either do it this way. This way works just fine. A lot of people actually prefer this way. But if you'd rather just do numbers, I'll show you what I like to call taking inventory. If you ever work at a job, all right, a lot of times you have to take inventory. It's just taking, learning about what things you have in storage, right, and counting it. All right. So I have my reactants and my products. So on my reactant sides, let's take inventory. I have a xenon, and as of right now, I have 1 of them. And I have a fluorine, and currently I have 2 of them. On my product side, I have a xenon. Currently, I have 1 of them. And I have fluorine, and currently I have 6 of them. All right, so now we need to make sure it follows the law of conservation. Started with 1, ended with 1. Started with 2, ended with 6. Doesn't work. All right, and so what I need to do is add a coefficient. More specifically, I need to add a coefficient here, which goes in front. I need to add a number right there to do this. I cannot change the subscript. Cannot change the subscript, because that is something else. All right. But I need to think about, okay, when I went down here, right, that told me how many of each of I have. If I have 1 fluorine, I need to think about what number, and then I'm kind of distributing. How many more F2s do I need? All right. I need 3 of them. Here, kind of a little side note here, that 3F2 is literally saying that there are 3 of these. 3 F2s. All right? So there's 2, 4, 6, or we just distribute. 3 times 2 is 6. So I always have to, whenever I do change this, I need to change my inventory. That changes this to a 6. All right, because 3 times 2 is 6. All right, let's check it again. Take. I'm all balanced. All right, technically there's a 1 here and a 1 here, but if there's no number, you do not need to take. You do not need to draw it. If it's left blank, we assume it's a 1. All right, this one's a little tricky. All right. Let's say you can do it either way you want. I want you to pause right now. All right. Pause it. I want you to try it on your own. You can either do the numbers or just using the pictures. All right, done. Okay. I'm going to do it with the taking inventory first. All right. So if I wanted to do it this way, let's start with what we have. On the reactants, I have 1 gallium. Then on the products, I have 2 sulfur. I'm sorry. On the reactants, on the products, I have 2 gallium. And I have 3 sulfur. All right, so pick one, just like when we did bonding. Pick a problem, fix it, and then retake inventory. All right, so I need to have 2 galliums over here. All right, so I need to think about what number can I put right here times 1. It's going to make 2. So if I put a 2 here, all right, that's going to change this to a 2. My galliums are balanced. Fortunately, that did not fix my sulfur problem. That one looks a little harder. Well, you can only use whole numbers. There is no number I can put here. What number times 2 equals 3? The answer is 1.5, but we can't have half a sulfur. So it's got to be whole numbers. So I need to think about where is a place that 2 and 3 both meet together. 6. So if I could turn this into a 6, all right, that changes. If I put a 3 here, 3 times 2 is 6, right? And that means I would need to turn this into, I need to put a 2 here. Now, here's one thing. That 2 goes to both the gallium and the sulfur. 2 times 2 is 4. 2 times 3 is 6. All right? So I fixed my sulfurs, but now I have a new problem. My galliums are off again. All right, well, we could just go back. What do I need to put here? I could even go back and just go start this part over if I wanted to. Well, what number can I put here to make it 4? Oh, well, if I just put a 4, now I'm balanced. All right. Sometimes you have to go back and forth. And if you're not sure, if you got it right at the end, retake inventory, which just means recount what you have on both the reactants and the products. The more you do these practices, the better, the easier it gets. You start to see certain patterns. You start to kind of figure it out. How's it go? This one was a tricky one. If you tried this one on your own and you were stuck, that is okay. This is one of the more tricky ones. All right. I always like to say there's easy, medium, and hard problems. This is borderline, medium, hard. All right, there are harder ones, but as you get more practice, you can probably do those ones as well. All right, so that's going to be on just practicing on showing some balancing equations. We'll practice a lot more of those going forward. So otherwise, that's going to be it for right now. Thank you very much. Good luck, and may the science be with you.